Humans have always looked up to the sky with wonder. Since we first looked up at the stars, we have wondered if there was life out there beyond our world. We've dreamed of traveling among the cosmos and visiting distant planets. More than ever, this dream is becoming a reality. Space tech has been revolutionized in recent years. Reusable rockets, crewed missions to Mars, and groundbreaking discoveries about the universe are just some of the ways that space travel is becoming more accessible. If you are looking for an exciting career with lots of opportunity, a career in space tech might be perfect for you. Keep watching to learn about some of the most revolutionary space tech in existence today and how they are rechanging the world around us. Rocket propulsion systems. These are responsible for launching spacecraft into space. They can be powered by a variety of sources, including chemical reactions, electric or magnetic fields, or even solar energy. The most common type of rocket propulsion system uses chemical reactions between fuel and oxidizer to generate thrust. This works by mixing the two substances together in a combustion chamber where the reaction produces hot, expanding gases that are expelled through a nozzle at the rear of the rocket, propelling it forward. Electric and magnetic fields can also be used to accelerate charged particles such as ions or plasmas to create thrust. Solar energy can also be harnessed by using large sails made of reflective material to catch the pressure of sunlight and drive a spacecraft forward. These systems are still in development, but show promise for future space exploration missions. No matter what the power source may be, rocket propulsion systems are essential for spacecraft to overcome Earth's gravitational pull and reach orbit or higher speeds necessary for interstellar travel. These are the engines that power the rockets, enabling them to launch spacecraft into space. There are several different types of rocket engines, each with its own advantages and disadvantages. Chemical rocket engines are the most common, and they work by burning fuel and oxidizer together to produce thrust. They're relatively inexpensive and easy to manufacture, but they're not very fuel efficient and produce lots of pollution. Electric propulsion systems, on the other hand, are much more fuel efficient, but they're also much more expensive and complex. These systems use electricity to accelerate a propellant, such as xenon gas, and produce thrust. Regardless of the type of engine used, rocket engines are critical for launching spacecraft into space. As technology advances, new and improved engines are being developed that offer better performance, efficiency, and safety features. These advancements are essential for achieving the ambitious goals of space exploration set by various organizations and private companies. Whether it's launching satellites into orbit or sending probes to distant planets, rocket engines are the driving force behind our quest to explore the universe. These are structures designed to carry astronauts and/or spacecraft into space. They can range from small one-person capsules to large enough vehicles that can transport multiple people and cargo. Capsules typically consist of a crew compartment, a service module that provides essential functions such as life support and propulsion, and a launch escape system that protects the crew in case of an emergency. Some capsules are also equipped with landing legs that allow them to make a vertical landing back on Earth. One example of a space capsule is SpaceX's Dragon capsule, which is designed to transport both crew and cargo to the International Space Station. Dragon is a reusable capsule that consists of two main sections, a crew module and a trunk. The crew module is where the astronauts will sit during launch and re-entry, while the trunk contains equipment and supplies. Dragon is also equipped with 4 cold docking ports that allow it to be attached to the ISS using specialized robotic arms. In addition to transporting crew and cargo, space capsules also play a vital role in scientific research and exploration. For example, NASA's Orion capsule is designed to carry astronauts on deep space missions beyond Earth's orbit. Orion will be used in conjunction with the Space Launch System SLS rocket to send astronauts to the Moon on the Artemis program with the goal of establishing a permanent presence there. Overall, space capsules are essential for human exploration of space, and they continue to evolve as technology advances, enabling us to venture further and conduct more research than ever before. These are uncrewed spacecraft that are used to explore and study the planets, moons, and other objects in our solar system. They typically consist of a body that houses scientific instruments, such as cameras, spectrometers, and other detectors, as well as a power source, communication systems, and propulsion systems that allow the probe to navigate through space. One example of a space probe is NASA's Voyager 2, which has been exploring the outer solar system since 1977. Voyager 2 has made incredible discoveries such as Neptune, its rings, and the first evidence of an impact crater on Titan. Another example is the European Space Agency's Rosetta spacecraft, which successfully landed a probe on a comet for the first time in 2014. Rosetta's mission was to study the composition and structure of comets and their significance in the origin of life on Earth. Space probes are typically launched using rockets, and they can travel to destinations throughout the solar system, including other planets, moons, asteroids, and comets. Once a probe reaches its destination, it can orbit the object of interest, land on the surface, or make close flybys to collect data and images. Space probes are essential for advancing our understanding of the universe, and they continue to be an important tool for astronomers and planetary scientists, with ongoing missions to explore objects throughout our solar system. We can expect to make many more exciting discoveries in the years to come. These are large structures that are placed in orbit around Earth or other celestial bodies, and they serve as a platform for conducting scientific research and other activities in space. They can be used for a variety of purposes, including scientific research, Earth observation, communication, and navigation. One example of a space station is the International Space Station, ISS, which is a habitable artificial satellite in low Earth orbit. The ISS is a collaborative effort involving multiple space agencies from around the world, and it has been continuously occupied since November 2000. It serves as a platform for conducting scientific research in microgravity and for testing new technologies in space. Another example is China's Tian space station, which was launched in April 2021 and is expected to be fully operational by the end of 2022. The Tian station will be used for a variety of purposes, including scientific research, technology development, and space tourism. Space stations typically consist of multiple modules that are connected together in orbit, and they provide astronauts with a place to live and work while in space. The modules can include crew quarters, laboratories, airlocks, and docking ports for receiving visitors. Space stations are usually equipped with advanced technology for communication, navigation, and life support, and they allow humans to stay in space for extended periods of time. These are reusable vehicles that are designed to transport both crew and cargo into space. They typically have a crew cabin, a cargo bay, and propulsion systems that allow them to fly horizontally like an airplane. One example of a spaceplane is SpaceX's Starship, which is a fully reusable transportation system that is intended to carry both crew and cargo to Earth orbit, the Moon, and eventually Mars. Starship consists of two main components: a spaceship that carries the crew and cargo, and a super heavy booster rocket that provides the initial thrust for launch. Another example is the Space Shuttle, which was operated by NASA from 1981 to 2011. The Space Shuttle was a partially reusable winged vehicle that consisted of an orbiter, two solid rocket boosters, and an external fuel tank. The Space Shuttle was used for a variety of missions, including deploying satellites, conducting scientific research, and building the International Space Station. Spaceplanes offer several advantages over traditional rockets. They can be launched and landed like an airplane, which makes them more flexible and cost-effective. Additionally, they can carry larger payloads and travel faster than traditional rockets. Spaceplanes are still in development, but they hold great potential for the future of space travel. These are unmanned aerial vehicles that are designed to perform specific tasks in the Earth's atmosphere. They can be equipped with various sensors and equipment to perform tasks such as surveillance, reconnaissance, and delivery. One example of a drone is the DJI Mavic Air, which is a small quadcopter that is popular for aerial photography and videography. The Mavic Air has a camera mounted on top, and it can be controlled manually or using pre-programmed flight paths. Another example is the Amazon Prime Air drone, which is designed to deliver packages to customers in a fast and efficient manner. The Prime Air drone can carry small packages up to 5 pounds, and it can travel up to 30 miles per hour. Drones offer several advantages over traditional methods of performing tasks. They can be smaller and more agile, making them able to access hard-to-reach areas. Additionally, they can be equipped with specialized equipment to perform tasks more efficiently or accurately than humans. Drones are still in development, but they have the potential to revolutionize a variety of industries, from agriculture to delivery services. These are computer-controlled robots that are designed to perform repetitive tasks with precision and accuracy. They can be used in a variety of settings, including factories, warehouses, and even outer space. One example of a robot is the Universal Robot's Year 5, which is a collaborative robot that is designed to work alongside humans. The Year 5 can perform a variety of tasks such as assembling products, packaging items, and even cleaning surfaces. Another example is NASA's Curiosity rover, which is a robot that was designed to explore the surface of Mars. Curiosity has a drill that can bore holes into rocks and soil, allowing scientists to analyze the composition of the planet. Robots offer several advantages over humans when it comes to performing repetitive tasks. They can be more precise and accurate, and they don't require breaks or sleep. Additionally, robots can be programmed to work safely in environments that are dangerous or hazardous to humans. Robots are still in development, but they have the potential to revolutionize the way we perform tasks in a variety of industries. If you enjoyed this video, be sure to leave us a like and subscribe so you never miss any of our newest videos. And if you're interested in learning more about the amazing breakthroughs in science and technology, click the video on screen now. Thanks for watching.